In this video, we will set up a simulation of a bracket component in the linear structural validation application, to investigate the displacement and stresses created in the component due to the application of a force. The simulation model is a bracket which is fixed at the two bolt locations at its base, as shown in figure. An 8900 Newton force is applied to the base of the cylindrical face. The objective of this simulation is to determine the bracket displacement and stress distribution under the applied loading. In this video, we will continue with the model that was imported to the linear structural validation application, using one of the two methods described in the previous lesson. Once the bracket model is imported to the linear structural validation app, notice that the active application name is shown in the top left corner next to the compass. Make sure that the collaborative space, where you wish to save your simulation on the platform, is set as the default. Next, enter the title of the simulation as Bracket Structural Simulation. Under the analysis type, select Structural. Click OK. Now, the model is ready to be set up for simulation in the linear structural validation application. As mentioned in the previous lesson, this application consists of a guided assistant, which provides a step-by-step workflow for the simulation setup. The assistant launches automatically with the application. It can also be launched by clicking on the Setup tab in the action bar and then clicking the Diagnostic Viewer flyout, or by right-clicking anywhere in the graphics window. All the simulation features can also be accessed using the action bar at the bottom of the application window. Before starting the simulation setup, the steps to be followed are described here. The first two steps of importing the model to the simulation application, as well as entering the simulation title, and selecting the analysis type have been demonstrated already. The third step involves applying material to the component. This is followed by step 4, which involves applying fixed displacement restraint to constrain the degrees of freedom of the model. The next step is to apply the desired loading. Once these steps are completed, step 6 is to run the simulation. The last step is analysis of the results. Now, let's start the simulation setup. The first step is to assign the material to the model. To do this, select the material palette from the Materials section of the assistant. Under Filter, type Alloy Steel. Drag and drop the alloy steel material definition onto the bracket component. Click the green checkmark to apply the material. A green tick will appear next to the Materials section of the assistant, denoting that the material has been applied. The next option under the assistant is Connections. This option defines the manner in which a component is connected to other components in an assembly. Since the simulation model in this study is an isolated part, we do not need to define the connections. The Connections option will be explored further in the next lesson. Now, let us define the restraints for the model. Restraints define ground interactions, to include the effective components that are not explicitly modeled in the simulation study. To do this, click on the Fixed Displacement command from the Restraints section of the assistant. This brings up the Fixed Displacement Property Manager. Select the inner cylindrical faces of the two bolt holes as shown. And under Translation, toggle on the X, Y, and Z checkbox. Click OK to close the command window. A green tick next to the Restraints section of the assistant denotes that a restraint has been applied. The next step is to apply external loads to the model. Select the Force option, under the Loads section of the assistant. Select the base of the cylindrical section of the bracket under Support. Enter 8900 Newton under Force. Click OK. The simulation assistant updates, and a green tick next to the Loads section of the assistant denotes that a load has been applied. In the next video, we will learn about meshing, solving the study and post-processing the results.